Hey YouTube fam, welcome back to another episode of Code with Annie. In this episode, we're going to be looking at the concept of abstraction in Java. So, what is abstraction? Abstraction basically means hiding the implementation details. So, when I say hiding the implementation details, what I mean is, let us say you are driving a car, right? You put the gear on, you put the keys in, you start the vehicle, you put the car in drive mode, assuming it's an automatic car, and you just press the accelerator and you're good to go, right? So behind the scenes, what happens is within the car, as soon as you turn on the ignition, there is the spark plug which will produce the spark needed for starting your engine, and that will start up your car. And the moment you put it on drive mode, automatically the levers come into action and your vehicle starts moving as soon as you press the accelerator. So there is a lot of things that happen within the car which you are not aware as a person when you start driving it, because you know that only if I start the car and I put it on drive mode and I accelerate, I'll be able to move forward. So this is the only thing that is exposed to you from the car's standpoint. Whereas the car's internal working is completely abstracted from your eyes. And that is the fundamental principle of abstraction in the real world, which is translated into the world of programming as well as in the world of Java. So let us take an example of how abstraction works. Let's create a new class. I'll call it as shape. Okay, this is a very basic example I'm going to take. Now, if I want to declare this class as abstract class, basically I want to hide the implementation details of this class. All I'm going to say is abstract public class shape. So this keyword abstract, if put before a class, will basically make it abstract. When I say make the class abstract, two things will happen. One, it will have the option to host abstract methods. I explained methods before in my previous video. Methods refer to behavior of your class. So you can make the methods as abstract. Second thing is it will have the option to host non-abstract methods as well. So when I say this is a very special class because any normal public class in Java cannot have an abstract method, but an abstract class, on the other hand, can host both the abstract as well as non-abstract methods. So basically, I can have a default behavior or implementation for this class, but at the same time, also have abstract classes whose implementations will be defined by the classes which extend the shape class. Now, extension is the concept of inheritance, which I'll talk about in another video. But for this particular video of abstraction, I'm going to focus on how abstract methods get implemented. Okay, so two things. It'll have abstract and non-abstract methods, and it is not possible for me to create an object of this class. So that is the other thing which I forgot to mention here, which is it will be not possible to directly initialize an object for shape class. What I mean by that is shape space shape equal to new shape without having an implementation for the abstract methods. Now, how will an abstract method look like? This is how it looks like. Let's say a shape has a method called abstract double find area. Okay, it takes a value. Let's say I want to find the area of the shape, right? So I can have, let's say, dimensions. Oh, I'm sorry. I think I imported a different internal library. Let's say dimensions space dimension. I can say dimension class. I don't have a conflict, so I will say dimension space dimension. Sorry. Yeah. So what I'm going to do is in abstraction, I'm going to create another class called dimension. add that. And in this dimension class, what I'm going to have is private length, private int breadth, private int height, private int. What else? What else? What are the dimension properties do you know? For example, length, breadth, height is one thing. You have radius, right? To calculate for circles. Let's just limit it for these four for now. So I can have dimension of, this is a constructor for this class. Constructors basically mean, this is another concept in Java, means these, as soon as you create an object for dimension, you can have values for these passed in to a particular method, and constructor is a special method which is actually having the same name as your class name. So dimension, say int length, int breadth, int height, int radius. Okay, I'm going to assign the values to the ones we have here. This dot length equal to length, and I said this is also a keyword which refers to this particular class. And I said this dot, I can refer to everything that's defined at the class level. For example, the length, breadth, height, and radius, which are defined inside the class directly, can be referenced using the this variable. So this dot length is equal to length, this dot breadth equal to breadth, this dot height equal to height, and this dot radius equal to radius. Right. As soon as I define this, I can say get. So you can have four getter methods for these. Let's easy way to do or generate the methods is through this. Let's say create getter and setter for length, create getter and setter for width. Probably can just get the getter because the setter is done through the constructor. Getter for height and getter for radius. Right. So set length is not needed. So you have get length, breadth, height, radius. Correct. So all things passed, and dimension class is this, and this is the class that we are using here. It takes the dimension and you can find the area using the dimension provided. Now, observe this class very carefully, right? This is an abstract class shape which has one method called find area. So I can have n number of shapes, all right? So anyone who extends this class, let's say there's a class rectangle. Let's create a new class here, new Java class, rectangle, okay? Extends shape, and it's asking, immediately throwing an error saying that, okay, there is an abstract method within shape which has to be implemented if rectangle is going to extend it. Otherwise, just make rectangle as well an abstract class. See, immediately error goes away. But our intention is not to make rectangle abstract. Our intention is to have an implementation for the find area method. So let's say I want to implement find area. So find area is currently written in 0, but what I'm going to do is, this is a rectangle, right? So the implementation will be rectangle specific. So I will say dimension dot get length into dimension dot get breadth. That's it. But this is the implementation for rectangle class. Likewise, I can have one for, let's say, circle. Okay, exact same thing. Circle extends shape. Immediately the error comes up saying I need to implement the find area, which is fine. We'll just do that. We'll go ahead, perform the implementation. I'm going to say pi r square, right? So let's take pi as 3.14. So 3.14 star, which is dimension dot get radius into, again, r square, right? So dimension dot get radius. That's it. This is the area of the circle. Or I can say math dot power of dimension dot get radius comma 2, basically, which is the square of this thing. But for simplicity and ease of understanding, I just put it this way. Now we have two implementations of shape, rectangle and circle. Let's go ahead and create a main class, or let's use the main class we already have here. So this was the previous vehicle example. I'm going to remove this. I'm going to say shape space shape is equal to, oh, I have to import, let's say, okay, let's take that. It's saying import this. Let's import the class. Shape is present in org abstraction. I'm going to take that because there is an internal library method shape as well as Java AWT package, which I don't want to take. I'm focusing on this one. Shape space shape is equal to new rectangle. Now you might have a question like, what am I doing here? Shouldn't it be rectangle space rectangle equal to new rectangle? That is also technically correct, but when you have this particular way of writing or creating your object, I'll tell you the benefit of this. Okay, let's go ahead with this first. So you have shape space shape is equal to new rectangle. Now you have to also have the dimension class, right? So let's define dimension space dimension equal to new dimension of. I need to specify the different parameters because dimension accepts four parameters: length, breadth, height, and in radius. So let's say 10, 10, height is 5, radius is 6, for example, right? So dimension class is created. Is it not public class? It is public class. I don't understand. It's taken from the right package. I don't see an issue here. Oh, the constructor has to be explicitly defined as public. So we keep that in mind. If we don't define it, it takes it as a private, I guess. So, or it's package level public, but not exposed outside because main is outside the abstraction package. So define this as public and that error should be gone. And here we have the instance of dimension, instance of shape, which is actually a rectangle. So note that it is not a new shape, it is a new rectangle. So this particular object has the capability of accessing all the rectangle specific methods, that is methods only within the rectangle plus the methods within the shape. So that's the reason why you initialize like this. That's one of the reasons. I'll tell you the other one later. Now we can say shapes dot find area. What is that method again? Within shape, find area. Yep. Here as well, make it public abstract so that you can know or access it through this and find area dimension. That's it. So you have shape dot find area dimension, and this should give me go ahead and invoke the rectangle shape, and it will find out the area of the rectangle. All right. Is it public? Yeah. Same thing for this one. So because your superclass method was public, you just have to make this as public. Return value is never used. Yes, you are returning it because you're not doing anything with it. I'm going to just print it out and say south. Okay, so here we go. And if I run this, I should be able to see 10 cross 10, 100 as the result. Hopefully no errors. Fingers crossed. All right. And here we go, 100.0. Because it's a double, it's going to append the point and put a decimal. So we got the result here. Same thing I can do with, this is rectangle, right? I can do the same thing with my circle. Say shape space shape 1 equal to new circle. And I can say shape dot find area dimension. Automatically, it will take the radius from the dimension and will calculate the area of this one, shape 1, sorry. If I run this, I should see 3.14 into 6 into 6, 36 into 3.14. Whatever it is, I'm not going to calculate it in my mind, but I can show you here. This is the result, 113 point this. Because we didn't put a cap on the number of decimal places to be seen, it's printing the maximum here. So that should be okay. That I'll address in another video when I explain you concepts on different data types. So for this video, yep, we got the rectangles area, we got the circles area, and both the cases we're using the shape interface to hide the abstraction of find area because find area's implementation is hidden within rectangle. It's a different one, and within circle, and circle's implementation is a different one. So this is the concept of abstract classes and how they help in hiding implementation details as part of abstraction. There is another concept called interfaces, which I'll talk about in the next video, and I'll explain you how they differ from abstract classes and what are the benefits of it. So that's not for this video. If you like this video, hit the like button, subscribe if you haven't already. I'll see you guys in the next one.